Today we're on page 3 of our chapter 10 notes. We're looking at arc length. Okay. We have a new formula. S equals theta r. So something you have to memorize. S equals theta r. Let's write it over here. S equals theta r, where S is the arc length of a circle. Theta is the measure of the central angle in radians, and r is the radius of the circle. Now note, your arc length and your radius must be in the same units. And don't forget, your central angle has to be in radian measured. Now what we have here is we have a diagram of a circle with a radius of 2 centimeters, an arc length, one arc length of 2 centimeters has a central angle of 1 radian measure, right? And then another one, this arc length of 4 centimeters would have a central angle of 2 radian measures, and the arc length of 6 centimeters has a central angle of 3 radian measures. So this is very similar to what we did with our paper plate activity and the ribbon. We used the ribbon. We measured out the radius of the circle and then used the ribbon to measure the arc length around the circle each time. All right. So this is just more of a diagram example of what we did in our paper plate activity. All right, but this formula goes along with word problems. We'll use this in word problems. So let me just finish this up here. For example, in the diagram, the arc length of 6 centimeters with the circle's radius of 2 centimeters would be intercepted by an angle of, all right, we counted 3 radians. Using the equation S equals theta r, our arc length of 6 is equal to our radian measure of our central angle, which was 3, times the radius of the circle, 2. 6 equals 3 times 2. If we wish to find the circumference of this circle, we learned that back in geometry that there are 2 pi radians and 360 degrees. So using the equation S equals theta r, S equals replacing theta with 2 pi, right, 360 degrees, in radian measures 2 pi times r. Here our radius was 2 centimeters, so we have 2 pi times 2, which is 4 pi. Now, our first example, we have the radius of a circle is 4 centimeters. Okay, so the radius of our circle is 4 centimeters. So r equals 4 centimeters. A central angle of the circle intercepts an arc of 12 centimeters. All right, the arc is 12 centimeters. This is our S value. What is the radian measure of the angle? Okay, so we take our formula, S equals theta r. S is 12. We're trying to find theta. R is 4. Sorry. Divide by 4. And we have 3 is equal to theta. So our central angle measure is 3. This is 3 radians. Is the angle acute, obtuse, or larger than a straight angle? So we're looking at 3 radians. All right, 3 radians. Is it acute, obtuse, or larger than a straight angle? All right, well, we're more familiar with degrees, so let's just take our 3 radians and convert it to degrees. So we'll take 3 radians, times it by 180 over pi. right? To convert radians to degrees, we multiply by 180 over pi. All right, and I'm actually going to use the calculator here. So taking 3 times 180 and dividing it by pi. Second, and the caret key, division by pi. So that's approximately 172 degrees. Okay, so this is approximately 172 degrees. So 172 degree angle, that's obtuse. So this would be an obtuse angle. All right. So if 3 radians is approximately equal to 172 degrees, then what is 1 radian approximately equal to? Well, we'll just take the 171, or sorry, we'll take the 172 and divide it by 3. So 1 radian is approximately 57 degrees. We just took the 172 and divided by 3 because 3 radians is approximately 172 degrees. So 1 radian is approximately 57 degrees. Our next example, the radius of a circle is 8 inches. Okay, so R equals 8 inches. What is the length of the arc intercepted by a central angle of the circle if the measure of the angle is 5 pi over 6 radians? Okay, so the 5 pi over 6, this is our theta value. All right, and we're looking for the arc length. So what is the length of the arc? That's S. We're trying to find S. So we go to our formula. S equals theta R. Substitute into our formula. S equals 5 pi over 6 times R, which is 8. And yes, we'll use a calculator and actually key in pi on the calculator. All right, so I think I'm going to use this fraction form. So I have alpha y equals 5 pi key, 5 pi over 6 times 8. So approximately 20.9. Let me write out the whole fraction, or sorry, the whole decimal. So S is equal to 20.943 95102. I think we'll round to the nearest tenth, let's say. So 20.9 inches. Okay. So the arc length would be approximately 20.9 inches. Right, in our next example, a central angle of 135 degrees intercepts an arc length of 10 centimeters. The central angle, 135 degrees, this is our theta value, all right? But remember, we must change to radians. Right, your central angle value always needs to be in radian measure. Intercepts an arc length of 10 centimeters, so our arc length is 10, so this is our S value. What is the length of the radius of this circle? Round the answer to nearest 10. All right, so we have S equals theta R. We're trying to find the radius. So let's see, how do I want to do this? Should I divide by theta or should I make our substitutions? Well, I think first, maybe we'll take the theta value of 135 degrees and let's convert that to radians. So we will multiply by pi over 180 to convert it to radians. And what's that fractional value? 135 divided by 180. Yeah, that's our 3/4 again. You could leave it as a decimal 0.75 pi if you like. But this would be 3 pi over 4 radian measure. Alright, so 10 is equal to 3 pi over 4 radians times r. Okay, we want to get r by itself. Instead of dividing by 3 pi over 4, multiply by the reciprocal times by 4 over 3 pi. What you do to one side of the equation, you do to the other, times by 4 over 3 pi. Okay, so now we have r is equal to, so these divided out. We have r is equal to 4 over 3 pi times 10. So 4 over 3 pi times 10 over 1. Now I'll go to the calculator. .24. We're rounding to the nearest tenth, so 4.2. Okay, so our answer is 4.2. And this concludes our video for tonight. Thank you.